Hi there. Welcome back to Spring into Math 7. I'm Mrs. Campbell. Today we're going to be talking about stem and leaf plots. Let's get started. Okay, so stem and leaf plots are another way to display data. This way of organizing and displaying data helps us to see values according to their size so we can order them accordingly. I want you to think about the base number system of 10, 100, 1,000, etc. We can organize numbers by ones, tens, hundreds, and thousands. So now we're going to look at the stem of a number so that we can organize it as part of a visual display of data. It's actually really easy, and I think it's super fun. So you might want to write this down. A stem and leaf plot organizes data in order. In a stem and leaf plot, each data value is split into a stem and a leaf. Now the leaf is the last digit to the right. The stem is the remaining digits to the left. So for the number 243, the stem is 2 and 4, and the leaf is 3. Couldn't be easier. Let's look at an example. It says construct a stem and leaf plot for the data below. Science test scores for third period out of 100, and you can see the scores there. They're not in order, from 97 going all the way up to 96. Step 1, we're going to arrange the data in order from least to greatest. That's pretty easy. And then step 2 is we just separate each number into a stem and a leaf. Okay, so you can see 68 is 6 for the stem and 8 for the leaf. 75 is the stem is 7, the leaf is 5. 77, the stem is 7, the leaf is 7. And for 79, the stem is 7 and the leaf is 9. And you can see the rest of the numbers. Pretty simple. And then step 3, it's important that we create a key and give a stem and leaf plot a title. So here's our answer. We're going to title it Science Test Scores for third period. There's our stems, there's our leaves. And the key, the way we write it, is 6 and then a line, and then 8. And that tells us that 6 being the stem and 8 being the leaf means 68. And this will be important as we get a little bit more involved in stem and leaf plots. Okay, so if you were to analyze this data, you could see that most of the values cluster around the stem of 9. And there's more numbers in that category. So, data from a stem and leaf plot can be used to determine the mean, median, mode, and range for a set of data. Let's take a minute and review our key terms. If you haven't already written these down, it's really important to do that. Okay, first of all, mean. The mean is the average of a set of data. To find the mean, add the data values and then divide the sum by the number of data values. The median is the data value in the middle when the data is ordered from least to greatest. Since the data is ordered from least to greatest on a stem and leaf plot, find the data value in the middle of the stem and leaf plot. Mode, remember mode is the one you see most often. The data value that occurs most often on a stem and leaf plot, the mode is the most represented leaf. That's really easy. And then range is the difference between the highest and the lowest data value. Let's look at another example. The stem and leaf plot below depicts the weight in pounds of the 10 trout caught in a fishing competition. Determine the mean, median, mode, and range of the data on the stem and leaf plot. So there's the weight of the trout that were caught. Let's look at the first one. The stem is 2 and the leaf is 9. This is where that key is going to be important. You see the 2 with the line and the 9, that means 2.9, not 29. That would be 29 pounds would be a very large trout. So 2.9. Okay, step 1, using the key, combine the stem with each of its leaves. The values are in order from least to greatest on the stem and leaf plot. Therefore, we're going to keep them in order as we list the data values. So we got 2.9, 3.1, 4.0, etc., etc. Step 2 is to recall that to determine the mean, you add the data values and then divide the sum by the number of data values. So we add up all the weights, 2.9 all the way up to 9.2, we get 60.2. We divide by 10, we get 6.2. So the mean is 6.2 pounds. Step 3, the data is already arranged in order from least to greatest. So to determine the median, we're going to identify the number in the middle of the data set. In this case, we've got 2 data values. We've done this before, so we should be pretty well practiced in it. Share the middle position. To find the median, we take the mean of those 2 data values. So we're going to add 5.2 and 6.2, which gives us 11.4, divide by 2, and then the median will be 5.7 pounds. Step 4 is to recall that the mode is the data value that occurs most. Looking at the stem and leaf plot, you can see that the data value 9.2 is the one that appears twice. So therefore, a mode is going to be 9.2 pounds. And then step 5, recall that the range is the difference of the greatest and the least values. On the stem and leaf plot, the greatest value is the last value, the one you see at the bottom, and the smallest value is the first value. That's pretty easy. It actually makes your job a lot easier. So 9.2 minus 2.9 is 6.3, so our range is 6.3. So there we have everything we need to answer this question. The mean is 6.2 pounds. The median is 5.7 pounds. The mode is 9.2 pounds, and the range is 6.3 pounds. All right, now we're going to take it a step further. Multiple stem and leaf plots are used to compare. Sometimes they're used to compare two sets of data, and that's what we're going to be looking at now. Multiple stem and leaf plots are displayed back to back to make comparisons easier. Here's our example. The multiple stem and leaf plot depicts the amount of time in minutes it took for students in 2 classes to complete a math exam of 25 questions. Use the information on the stem and leaf plot to answer the questions on the following slide. And I've got the stem and leaves on the next slide as well, following slide. So if you need to, pause the video and take a look at the stems and the leaves for the math exam. So let's ask ourselves, how many students took the test in each class? Well, that's actually kind of pretty easy to answer because there's 15 data values for class period 1 and class period 2. It can be inferred that there's 15 students in each class. How many stems are on this stem and leaf plot? On this stem and leaf plot, there's 5 stems. Determine the median for each class period. So looking at the data for class period 1, you can see that the median is 39. The median or data value in the middle of the set of data for class period 2 is 36. And then identify the modes for each class period. Again, that's the one you see most often. 2 modes occur in class period 1. The data values that appear most often are 25 and 51, and there's no mode in class period 2. So what is the range in data for each class period? The largest data value in class period 1 is 62 minutes. The smallest data value in class period 1 is 24 minutes. And the difference between the two, or the range, is 38. The largest data value in class period 2 is 60 minutes, and the smallest is 23 minutes. Therefore, the class range for period 2 is 37 minutes. And that's how we compare. The next one is to compare the mean for class period 1 with class period 2. And we want to recall that to determine the mean, we need to first rewrite the data using the key from the stem and leaf plot. Add the data values and then divide the sum by the number of data values. This is pretty easy. So we add them all up for class period 1 and we divide by the number of values we have, which we've already determined is 15. And we get 40.3 as the mean for class period 1. And then for class period 2, we do the same thing, add them all up, divided by 15, and we get the mean of 38.86. So let's look at what it says here in blue. Using a stem and leaf plot shows us what the data looks like. We could have analyzed the data in the same way if it had been written out, but looking at the data organized in a visual way can help us to keep track of the information and make conclusions based on the values presented. And I think it's actually easier, if you ask my opinion. All right, everyone, that just about does it for this lesson. Thanks for joining us, and we'll see you next time. Bye-bye.